hope you can hear my voice clearly. My name is Rania Zarenda, and I'm the manager of Keyviة Fab Lab. So in today's session, we're going to be talking about prototyping in general, especially when it comes to product development. So the word prototype is actually a word that came from a Greek, was originally from a Greek, which was divided into two sections, which is protos plus typos. Protos mean first, and typo means first impression. So basically, when we talk about prototype, we talk about the first impression. The first thing when you demonstrate something to, or when you present a product to someone, you need to get the first impression right. If you got it wrong, it might affect the long-term process of your company. So when we talk about what do we want in a prototyping or how we want to tackle prototyping, we'll talk about four main sections. We want the information phase, we want to know about the exploration phase, the design phase, and the test phase. So it's very important when you work with a prototype or when you want to develop your prototype to make sure that you go into these four iterations every time you adjust something in you or you want to produce a new prototype. So each phase I'm going to explain now separately, but in general, keep it as a rule. Whenever you have a prototype or whenever you want to tackle a prototype, these are the four main phases that you want to go through. So to understand this better, just consider or keep looking at this diagram. So you see that there are 5 different of blue shades. Each shade represents something. And if you saw the arrows in here, these are the iteration you have to take. These are the steps you have to take every time you are in one of this prototyping stage. So starting from the first stage, which is the product characteristic. So what you need to do is that you need to understand the characteristic of your product. So what you want to build, understand the kind of product you want to have, what industry you're going to have this product in, what are the adjustments that you need to do, and this kind of stuff. So for example, let's say that you want to prototype this pencil, this pencil, okay, or this pen. What you want to do is that you understand different kind of aspects, like how I'm going to hold the pen, where I'm going to use the pen. Is it like a very sophisticated pen or just like a daily use pen that you're going to have every day? So, okay. So by understanding the main important part, which is the product characteristic, you will move deeper into this circle or into this diagram. To move deeper, as I said, you will go through different iterations. So the first one is the product personality. Then you will consider the function, the use, material, shape, and manufacturing process. So starting from the product personality. Okay, when you say product personality, you want to understand, as I said at the beginning, what are the product you're developing? What do you want to prototype? Are you considering prototyping the entire product or just a small part on this product? So this is very important because there are a lot of misunderstanding that when we talk about prototype, let's say in a manufacturing scale, or we're talking about prototype in a very huge company, people will think, okay, then we're going to prototype each and every single stage of my process. And this is completely wrong. You can do that, but you can also just prototype a small part or like a small segment in your product. And this is all like understanding what you want to do or what you want to go through is the first main step that we're going to support you in the rest of the stage. The function, you want to understand what kind of function this product will carry. So as I said, going back to our example earlier, is it a pen that you're going to use every day? Is it a sophisticated pen that's meant to be for meant to be given as a gift? Is it, for example, a perfume? Is it a phone? Is it something? You need to understand the kind of function you wanna build. Because let's say you wanna prototype a phone, okay? You cannot do the same research you did for a phone to prototype a phone and to prototype a pen. When you want to prototype a phone, you need to understand the system inside the phone, what's going on inside the phone, what are the programs that you need to program, what are the the interface that you want to use. But if you wanna prototype a pen, you just have to consider a few less complicated features or less complicated functions. The use, as I said as well, when we talk about the use, you want to see, are you going to use it for a daily basis? Is it a daily basis product, or is it occasional product, or is it you're targeting a specific segment? So you need to understand how the pen is going, or how the product you want to prototype are going to be used. Are we going to place it outside under the sun? So we need to consider the kind of material we're using. We need to find a material that won't melt down during the day, or it's going to be inside home, so you don't care a lot about heat resistance when it comes to material. As well as material, shape, manufacturing process. All these processes you need to consider when you build your prototype. So if you looked at this diagram represented here, we have two stages of the prototype. We have the what and we have the how. When we talk about what we want to prototype, we talk about the product personality, we talk about the function, and we talk about the use. We understand these three aspects when we were asked when we developing our prototype. We asked these three questions: what are the product personality? What are the product function? And what is the use of the product? However, when we talk about how we're going to use this product, we talk about three main things. We talk about the material, the shape, and the manufacturing process. How we're going to choose the material, and what aspects we should consider choosing the material. How is the shape of the product? If it's something I'm going to hold for a very long time in my hand, is it actually designed properly to fit my hand, or to fit people's hand in general? Or I need to consider this aspect whenever I'm designing or I'm developing my prototype. Then the manufacturing process. So for example, here in Cubic Fab Lab, we have different prototyping technology, okay? So whenever you want to, let's say, prototype a trophy, it's completely different when you want to prototype an electronics PCB or BCB board. So when you ask yourself what are the things I want to consider, you talk about the product personality, the function, and the use. When you ask yourself how I'm going to do it, you consider the material, the shape, and the manufacturing process. As I said earlier, these iterations, these steps or these stages are all going into the same circle where you have to consider idea communication, idea selection, idea generation, and problem definition. Okay, perfect. So when we're done if we looked at the prototype in further scale, we see that the user experience, the process that we're going to go through to produce our prototype, and finally describe the technical aspect, given an answer on how desired user characteristic may be realized. So the stage that I just explained is very important if it was backed up by a related user experience. So for example, you know that there are hundreds of people who have been producing pens for daily use, and you know a lot of brand companies that have been producing pens for sophisticated use, or for as a part of accessory. Okay, so when you understand your target audience, or understand the related user experience of the thing you want to produce, or you have a similar back knowledge on the user experience of the things you want to produce, you'll be able to carry the steps that I just explained perfectly. But if you're starting from the scratch, if you're starting with something completely new, this could be very challenging when it comes to, okay, well, the thing I'm doing when it comes to personality, when it comes to function, use, shape, material, and manufacturing process. Is this basically what I want for my project or not? So when people talk about prototyping, when we talk about, okay, what is prototyping, what are the process that we want to go through when we prototype, there are, especially when it comes to startup or when it comes to SMEs, there's a lot of misunderstanding between what is a prototype and what is MVP. Okay, when I said MVP, many people will think about an MVP as a prototype, which is completely not true. MVP is the advantage step of prototype. When you're done with your prototype, you go through different iteration of MVP later on. But you cannot go directly through MVP without having an initial prototype. So if you looked at the diagram presented here, you have first a new idea. You have an idea that you want to present it. You do micro planning, you do computer, you carry on your analysis, and you do your prototype. As I said, like prototype is something very initial. Even though we considered the previous steps to produce the prototype, these are crucial when it comes to prototype, but prototype in general is the initial stage of the product development process. Then after that, you carry on, test again, get user feedback, understand what went wrong and what went right on your product, and then move to the MVP stage. I'll give you one example here when I talk about the MVP. I remember back, 3 years ago in Ruwad, I was with one of the startup. It was one of the engineers who worked with a startup, and we had this product. So basically, the product create energy, or it produce energy using your kinetic energy. So it transfer your movement into energy that you can use to power on your phone, your computer, or whatever. However, the first prototype that we had was actually looked like an ATM machine that you see whenever you go shopping. Okay, so whenever you pay in your credit card, the product looked like this. The first prototype of the product looked like this. So whenever we were presenting this, people were thinking that we're creating an ATM machine, and we were explaining for them what is the idea of this product, but they couldn't understand because the only thing they could concentrate on and they could see is an ATM like packaging. So we had this discussion with different people. We were like, no, this is actually a device that you can use to power your devices, such as your phone, your computer, from your kinetic energy. Then it was like, okay, then why it looks like an ATM machine? They couldn't remove this idea from their head. Like they couldn't scratch the fact that it looks like an ATM machine. So at this point, we realized like the first prototype we built, we did not consider the shape. We did not consider the outer shape or the personality of the product. So people thought that it's just completely something else rather than the thing we want to explain. So this is very important to consider while developing your prototype, even though if it's the initial stage of your product development process. This is something we face a lot here in the Fab Lab when we talk about the importance of prototyping, especially since we are like prototyping facilities or validation facilities where entrepreneurs reach us for like examine the first stages of their idea or validate their idea, or use the prototype that we produce for them to validate their idea. So we have like this a lot of let's say mentality where people think that prototype is something, it's additional stuff, a privilege that either I want to do it or not, like it's up to me, but they did not understand the importance of it or the real importance of it. So what I do is that I present for them an example of like a very sophisticated companies that do prototype in their daily basis. So if you looked at the picture I'm presenting here, this is BMW. They actually, before they manufacture the outer cover of the car or the outer body of the car, they actually they do the prototype using clay. like a very simple, easy use, easy shaped material such as clay to prototype how the archery body would look like in real life. Okay, and they also have like BMW, Range Rover, and like different kind of car manufacturing companies. They actually have a line of 3D printing technology embedded in their factory just for prototyping process. They prototype the smallest detail in their car to the biggest detail. So from the small screw they use inside the car to the car outer body, they do the prototype for each and every single stage, because they understand if they prototype, it will save them much more money if they, rather than if they immediately go and start the manufacturing process. Because when you prototype, you'll see like, let's say the use example. So if I'm going to use my phone, okay, I need to consider the way I'm going to hold my phone. So if I design something that is very bulky, very unuser friendly, people won't buy my phone. Maybe they would buy it at the beginning because, oh, it's something new or something sophisticated, but like I won't be able to generate like huge customer database. People buy it at the beginning, but then they will ignore it. So what you want to do when it comes to prototype is that you need to understand that this is an iterative process. It's not something that you build one time and you ignore it. It's something that you will build again and again and again until you are satisfied with what you have and you feel like you can pitch this to the customers or pitch this to investors or potential investors, and they're going to accept your product. So when you prototype, you'll understand your mistakes. You'll know that what you want to adjust, and every time you prototype and you get user feedback, you will get more and more into whatever you want to produce. You will understand more and more on what you want to do or how you want to shape your product, how you want to prototype your product. Going through this iterative process, and being very patient when it comes to prototype will help you a lot on producing your final product, and actually will let you reach to your target product faster than just like producing one prototype, then go to the investors, go to the market and try to pitch your idea. Such our case when we were pitching our idea. Okay, so as I said, like there's a difference between prototype, MVP, and a product. So if you looked at the donut example, this is like a perfect example of what is the difference between prototype, MVP, and product. So if you looked at the first picture, prototype could be like a digital file you have in your computer. It could be a simulation that you run in your computer. It could be like a plastic piece that you produce to check different kind of characteristics, such as the shape, the use, the material you're going to produce. Then you move to more into more advanced stage, which is the MVP, where you start test different kind of aspects. So let's consider a perfume company. So the first thing you want to prototype is the perfume bottle and the cap of the perfume. So first, what you want to prototype, or the first thing you want to do is prototyping. And for prototyping, I'm going to prototype the shape of the bottle, the adjustment of the cap with the bottle. Is it loose? Is it very tight? Is it perfect? You want to see how, like, you want to see the cavity of the perfume bottle. You have to prototype different kinds of aspects. Then you move to the MVP stage, where you actually prototype, or where you actually test different aspects of the bottle. For example, now you're done with the prototype, you're done with the plastic piece. Now I wanna try the actual glass bottle that I'm going to use in the market. Is the shape from the plastic to the glass changed? If it changed, what was the factor, or what was the cause of this change? if the adjustment of the cap when I change it from the plastic to the glass changed, do I need to do further adjustment? Do I need to go back to the plastic to adjust a few more characteristic of the perfume bottle, then move back again to MVP? And this is like, believe me, I know it's like a very tiring stage, but it's very important to identify the kind of product you want to pitch to the market. You go through an iterative, going back and forth from prototype to MVP. You'll do that for different iterative. You could be very lucky, and you could have done this in the first iteration, and you could be like very, like, I don't know, unlucky, and you do it over and over again until you get the final product, and until you're satisfied to get the final product, which is in this case, or in our case, is the donut. Okay, before moving anywhere, do we have any question? Okay. Seems like we're happy. Okay. So, as a part of a prototyping facility and as part of Cubic Fab Lab, I think it's very important for the entrepreneur to understand what are the facilities that offer such a service. Okay, so usually you can easily find a place where you can prototype your packaging, or find a place that could do a small prototype using cardboard. But it's very hard, especially here in Qatar, to find places where you can do a prototype. So that's why I want to introduce you to the services we have here in Cubic Fab Lab, and what are the things we offer for people to come and test, or to come and join us to do their prototyping stage. So first we have the 3D printing. So here in Cubic Fab Lab, we have different 3D printing technology. We have this one, which is the FDM. We have this one. It's also an FDM technology, but it's an industrial grade, meaning that you can print different kind of sizes using this printer. And we have the SLA, and we have the SLS. So I will explain each and every technology individually. So the first one, which is the Ultimaker Fdm Technology. So basically, this is the one we use whenever we talk about the prototyping stage, the first initial stage before going to any more advanced process. What's good about this 3D printer is that it's very cheap, and it's very user-friendly. So let's say you have a digital file that you want to prototype. We always advise to use the FDM technology first before going to any advanced services. And I'll give you like one example about that. I remember like 1 year ago, we had a customer who wants to prototype their perfume bottle, actually. Okay, and they have the digital file ready and they want to print. So he did already his research, and he understand what machine or what technology he want to use to print his digital file. However, I kept on advising him to go first to the FDM technology before going to any advanced service, and he agreed eventually. We did the dry run on Ultimaker, which is the FDM technology, and we figured out one issue most of the designer face, or most of the designers do, which is that they do not consider designing for manufacturing. They just do a conceptual design. So for his design, he did not consider the tolerance. He did not consider the outer shape or the way the bottle will be produced. He just did a very conceptual design, as if he was painting, as he was just like doing a normal 2D painting. So whenever we printed this using an FDM technology, the final product was very cannot be actually moved any further, and we had to do a lot of adjustment on it so we can print it again in FDM. So if we did not do that, we will not figure out that actually whatever he designed is not manufacturable. We cannot manufacture this product. So the second FDM technology printer we have, it's the WASP. Usually this printer is used by the artist, because They prefer to produce a plastic pieces or prototyping material plastic pieces, but in a larger scale. So WASP could be the best option for that. One good thing about the WASP is that you can either use it for a prototyping stage or you can use it for the MVP stage. Prototyping stage, you can prototype whatever you want on it. You can carry on with a dry test on it. But at the same time, if you want to move further in your process, you can still use the WASP since it's an industrial grade. So if you just do a fewer adjustment to its setting, it could reproduce for you a plastic piece, but it's similar to a product quality piece. The next thing we have when it comes to 3D printing technology is the Sla technology. So what's different about this technology is that it uses a liquid material, a liquid resin-like material, to solidify, to change the chemical property, and using the laser to change the chemical properties of this liquid to solidify it. This machine actually is not just a prototyping machine. It's not even an MVP machine, but this machine, you can find it even in the dentist office and even in the jewelry manufacturing offices. So what they do with this machine, you can either create the mold for your jewelry pieces, and it's a very well-known machine for that. So they have a specialized material for this machine that you can use to create the mold you want to use for creating your jewelry pieces. Also, I remember we had one of our client. She's a jewelry designer. She has her boutique here in Qatar, but she used to prototype the pieces using a real gold material. So she used to go to India to create the pieces, do the fitting here in Qatar, then go back to India if she has any further adjustment. So when we launched the lab, she came to us looking for this machine specific to create the mold for her pieces and to do different iteration here in Qatar to test the customized jewelry pieces she's designing. The last machine we have when it comes to 3D printing technology is the Sls Machine. So the Sls Machine is actually very similar to the metal 3D printing, which I know people might be confused whenever we say that we have a powder jetting machine. Powder jetting technology is usually referred to as the metal 3D printing, but whenever they were producing 3D printers, whenever they're producing desktop 3D printers, they consider to replicate whatever process they're doing in the metal, in the plastic, so it would be cheaper and faster when it comes to time and after processing. So in SLS, you actually can produce a very fine detailed pieces using powder material, which could result actually in producing similar to final product quality pieces. So for example, if you have a gear, if you want to prototype something that you're going actually to use in the market, this machine is capable to do that. And we actually use it into more advanced process whenever we prototype. We use it in the MVP too if we're satisfied with everything we've done with the previous 3D printers technology. If we think that we have done our job perfectly, we use this machine to test further process. Okay, another good thing, or another one of the, let's say, very hot services we have here at Keyvia's Lab is the 3D scanning. So whenever we talk about 3D scanning, people will think, oh, okay, so it's like taking, replicating whatever you have. Yes, it's replicating whatever you have, but you cannot just imagine the advantage of this one. So let's say you have a piece, or let's consider the car example again. You have a piece and you want to have, or you want to produce, or you want to purchase the spare part of this piece. But whenever you went to the original manufacturing or manufacturer, they told you that this piece would cost you, let's say, a couple of 10,000 Qatari riyal. So I remember one of our customer actually he had one spare piece that he wanted to create the digital file for it. He wanted to digitalize it. But whenever he asked the manufacturer for the file, they have a lot of process that you have to go through. You have to fill different kind of paper. And he actually did not want to use the piece as it is. He just wanted to do few adjustments to this piece so it could work for his new idea or his new product. He didn't want to choose, he didn't want to replicate the piece itself. He wanted to do a few adjustments on it. So it's not an issue of IP. He just wanted to do a few adjustments to this piece. So he came here to Cubic Fab Lab to digitalize the file using 3D scanner, which work as a reverse engineering. Instead of you design whatever you want to design, we actually scan the object, the physical object for you, and we digitalize it for you. You'll have it now on your computer, and you can do any further adjustment to it. So imagine, like, for example, if you're going to a dentist, or if you're going to if you have this technology in like a jewelry store, if you have it in a dentist office, or if you have it in a spare part manufacturing company, having the ability to digitalize whatever piece you have or whatever product you have could open different kind of business opportunity for you. I know a lot of people who, for example, know that if they carry a few more adjustments to whatever piece they have or whatever product they have, it could work much more better for them, and they could feel that customized version they did for themselves. It would boost their market even better. So that's why 3D scanning is becoming one of the hot technology here in Cubic Fab Lab. Then we have some technology that is called computer-controlled cutting. This technology, it cuts using different kind of cuts and engrave using different kind of technology, such as laser cutter, similar to the one I'm showing here, and to this one, and it could be a vinyl cutter. So these two machines actually are used when it comes to packaging, for gift shops, for flower shops, because you actually, whatever you're creating manually, you can create using these two machines. You can create it using the vinyl cutter or the laser cutter. So if you want to draw, or if you have a specific drawing, if you have a specific design that you usually do by your hand, using the computer control facilities, you can actually replicate this design very easily, or you can have as many number as you want from the same design, instead if you're doing it manually. And I know like different flower shops here in Qatar are now integrating these two technology in their process. So I know many shops in the Pearl, they use the laser cutter and they use the vinyl cutter to create their customized flower bouquet, or even like a gift for a different kind of occasion. So the difference between the two laser cutter we have in the Fab Lab, we have this one, a very big laser cutter, very big and bulky laser cutter. We use it to cut and engrave like a bigger scale material. But for this one, it's actually much more advanced than the first one that I showed, because this one actually, it's an industrial grade that is minimized for a desktop use. So for this one, you can actually cut even like a very small thickness of metal, and you can engrave a picture. Like if you have a picture, you can just put it on the computer and engrave it on whatever material you have. So when it comes to laser cutter, this one it's much more advanced than the bigger one, but in a very small scale. Then we have something called computer-controlled machining. It does basically the same thing as computer-controlled cutting, but using a bit technology, or using the drill bit technology. So for this one, let's say it's more like a workshop or a wood shop work, where we cut metal, we cut wood, acrylic, and different kind of material except for metal. We cut it or engrave it using this computer-controlled machining technology. So I don't know if you know about this, but there is a Fab Lab that is called Meta Fab Lab, we established last year this Fab Lab. So this is basically a Fab Lab for disabled people. So their idea is to enable disabled people to innovate. So one of their challenges there is that they want to have a furniture that could fit the movement of the disabled people. Like some of them would be set on the chair, some of them will have some disability when it comes to their movement. So like their main goal or their main aspect was whenever they want to design the Fab Lab, they need to take these under consideration. So what we did is that we support them in creating furniture pieces for them using the CNC machine that would, sorry for that, that would work for disabled people. And it's now established and running as we're speaking. Then we have the electronics production facility. When we talk about prototyping, it's not just about packaging, it's not about designing, it's also about the embedded brain inside products if it was required. So electronics is one of the main and important technology we have here in Fab Lab. So when it comes to electronics, we have from production to assembly to medium to small production. So we have electronics production machines such as the Volterra, which is the one that is showing right now, and the milling machine, which is called Ronald. So for Volterra is actually a startup that understood the need of the electronics production in different kinds of material. So if you're an electrical engineer, so you'll understand this perfectly. So if you want to produce a PCB board, like a normal PCB board, which is like similar to the motherboard you see in your computer or in whatever electronics device, you'll have to etch a copper board to remove the upper material to create the conductivity traces between the electronics. However, Volterra understand, okay, now we have different kind of applications. We have different kind of hot topics that are coming into whenever integrating technology into different kinds of aspects, which one of them is the wearable devices. So what they decided to do is that they decided to create or to replicate whatever process they have in electronic production using a very smart conductive ink material. So if you see that, if you know the henna, so basically the machine actually draw the traces or draw the PCB in whatever material you're choosing. So if you want to print it on your paper, if you want to print it on glass, if you want to print it on whatever piece, the machine is capable to do that. It will just like pour a conductive ink to draw the traces for you, similar to the small video you're seeing right now. And also, like with not just like creating the trace for you, it would even also help you in soldering the electronics into your PCB board, which is something very advanced when you talk about like a startup company that comes with such an idea. Milling machine or the Roland machine is basically a very classic electronics production machine where you have a copper board, you do the etching process in this machine to create your traces. So this machine basically we use for two different applications. We use it for the electronics production and we use it for creating molds. So like a very important part of Cubic Fab Lab is creating molds. And I think I could easily say that we're like the only facility here in Qatar where they can create a customized mold for you. What we do basically is that we know whatever mold you want to create, and we have done this even to different kind of coffee shops. One of them is the one in Qatar Museum. They have this chocolate that looks like the Qatar Museum that they want to put on the coffee when they're serving coffee. We did the mold for them here in Qatar. Then we created, after we melt the mold, we actually have, we cast the mold with edible material so they can use it as many times as they want, and they can use it directly with the customers. Like it won't affect, it doesn't have any chemical or any like regulations when it comes to food protection. So this machine is very advanced. We use it for electronics, and we use it for creating molds of whatever shapes or application you have. Finally, when it comes to electronics, we have the pick and place machine. As I said, we have in the Fab Lab, we have the electronics process from production to assembly, to small and medium production. So let's say if you have like a set of 5 PCB that you want to solder, you want to put the electronics on it and solder it. It would take you forever if you do it manually. So what it does, this machine, is that you put your electronics on it, you put your PCB on it, and it helps you assemble a different number of PCB at the same time. So let's say you want to assemble 5 pieces, 10 pieces at the same time. This machine will help you to do that with no time, like within like 2 minutes, literally. Finally, like this is like a new thing that we started in the Fab Lab last year with the launch of the Fabric Academy program. A program that integrates textile and technology. We launched the Smart Textile corner here in Keyvic Fab Lab, where we have different kinds of machine to create a small or to produce a smart textile process here in the Fab Lab, either by integrating technology into it or by examining different kind of biomaterial or smart material, which offer the sustainability option for you. The CAD process, we're not only talking about machine. Sorry, we're not only talking about the machine here, but we're also talking about the manpower and the expertise we have here in Keyvic Fab Lab. So we're like a team of electrical engineer, mechanical engineer, mechatronics engineer, and even industrial designer. So if you have an idea, but you don't know how to start, from where to start, if you actually have the design in mind, but you don't know how to execute it, and you don't have any physical product that we can really scan for you, we also have the service here in Keyvic Fab Lab to create the digital file for you, to help you creating the digital file, to help you use the different kind of CAD/CAM tools to support or to speed up your process. And these are some of the examples we have created in the Fab Lab. So this is the Sla machine, the resin machine, the one I told you we used for the jewelry piece. This machine actually very advanced, can create a very high-end product for you, and these are examples of these products. These are example of the ring cast that we did for the jewelry designer I've mentioned earlier. These are example of a 3D scanning process. So this customer actually had he had the car hook, the adjustment, he wants to readjust the piece itself. So we 3D scanned the piece for him to digitalize it. Then he do a further adjustment to it, and then print it back using a plastic or FDM machine. So you could see if the adjustment that he required was met, or he needs to do a further adjustment to the file. And these are some of the examples that you can do using the CNC and the laser cutter machine. There's like one good thing about, let's say, digital manufacturing is that you can actually create something without the need of screws, without the need of rod or anything. You can just do a smart design where you connect your pieces using the wood itself. And I don't know if you come before to the Keyvic Fab Lab, you could have seen one of the examples on the front door. We create some of the sculptures, some of the pieces without actually screw any of them. So it's a very advanced process if you're very interested on that as well. These are some examples of the vinyl cutter, the laser cutter, and the CNC machine. You can see over here, these are the examples that you can use with this kind of machine in terms of design, in terms of if you have like a gift shop idea, these could be a very good examples for that. And yeah, this additional example, this is an example of molds that we can create for you. One of the molds that we've created was for a planter. he wants to create like a very new way, a new shape for a planter. Like he didn't want to go to the boring shapes of the planter. He wanted to create funny shapes that he can place on his house. So he used the molding and casting service we have here in Keyboard Fab Lab. Some more examples out of that. These are some of the pieces you can create using the SLA and Sls Machine. And as I said, these are product ready. Like, these are not prototype facilities. These could be used as a final product, and people have actually used it before to produce a final product, not just for prototyping. So yeah, I think I'm done here. Let me know if you have any question. Does anyone have any question? Please feel free to ask the question on the Q&A button. Okay. Tamam, I think if no one has any question, we can end the session here. Thank you all for joining us for today. It was very pleasure meeting all of you, and I hope that session was you learned something from this session. Please let me know if you have any further questions. I think that you already have my contact details from the poster. And please let me know if you want to contact me in person, or if you want to have any, if you want to visit Cubic Fab Lab, or if you have any specific question for Cubic Fab Lab, please feel free to either send it here or to share it with the committee, and they're going to share it with me. Thank you all, and have a great day.